Hello students, in this video we are going to discuss 6.1, 6.2, 6.3 and 6.4 from system of particles and rotational motion of class 11. In this 6.1, give the location of center of mass of sphere, cylinder, ring, cube, each of uniform mass density. Does the center of mass of a body necessarily lie inside the body? Coming to the first one, we have to locate the center of mass of sphere. For the sphere, the center of mass will be located at geometrical center of the sphere, and for the cylinder, this one will be center of mass at center of its axis of symmetry. That means if it is the if it is the cylinder, then that one will be at this point. For the sphere, this one will be at the center. Coming to 3. For a ring, for the ring, center of mass will be at center of the ring only. So at the center. While coming to fourth one, for cube, center of mass locates at point of intersection of the diagonals of the cube. So these are the points where the center of mass locates for the bodies if they are having uniform mass density. Now one more sub question: does the center of mass of a body necessarily lie inside the body? For this one is answer no. Coming to 6.2. In the HCl molecule, the separation between the nuclei of the two atoms is about 1.27 angstrom. Find the approximate location of the center of mass of the molecule given at the chlorine atom is about 35.5 times as massive as hydrogen atom, and nearly all the mass of an atom is concentrated in its nucleus. Here we can assume that this HCl molecule will be like this. I am taking for hydrogen like a dot, for chlorine somewhat bigger, because the size of the chlorine is higher with compared to hydrogen. We can take this along x-axis, and this is suppose say origin. At origin, hydrogen is located. Its position is 0, and the position of chlorine from origin is suppose say x2. So this value is 1.27 angstrom. Now somewhere the center of mass can be located here. So this one we have to find out. So the formula, suppose say it is a distance x from hydrogen. The distance of center of mass is x from hydrogen, that is from origin. So we can write this x as x is equal to m1 x1 plus m2 x2 divided by m1 plus m2. Here we can take m1 is mass of the hydrogen, that is simply m, and m2 is mass of chlorine, that is 35.5 times of mass of hydrogen according to the given data. That is equal to m1 into x1 is 0 plus m2 is nothing but 35.5 times of m into x2 is nothing but 1.27 angstroms divided by m plus m1 is nothing but m2 is nothing but 35.5 m. That is equal to, we will get 35.5 into 1.27 m divided by, so 36.6 m. M will be get cancelled. So this value is nearly 1.235 angstroms. That means the position of center of mass you can denote with the Cm or Com, no issue. From hydrogen is given, that is x is 1.235 angstrom. Otherwise we can write the answer, position of center of mass from chlorine can be taken as, that is some 1.27 minus x, that is equal to 1.27 minus 1.235, that is also is equal to nearly 0.035 angstroms. Any one thing we can write it. Coming to 6.3. A child sits stationary at one end of a long trolley moving uniformly with a speed v on a smooth horizontal floor. If the child gets up and runs about on the trolley in a manner, what is the speed of center of mass of the trolley plus child system? Here the trolley and the child is taken like a system. So if the child is running, there will be an internal force, but external force is 0. That means F external is equal to 0. That means there won't be any acceleration or any change in the position of center of mass. Therefore, what we can answer say, what is the speed of the center of mass? We can write that there will be no change in the speed of center of mass of the system. F external is 0, so acceleration is 0, and the center of mass speed will be remains same. There won't be any change in the speed of center of mass. That means speed will be v only. Coming to 6.4. Show that area of triangle contained between the vectors a bar and b bar is 1/2 of the magnitude of a bar cross b bar. Suppose say if we are taking a triangle which is made up of two vectors, so that is vector a bar, it is vector b bar, angle between them is suppose say theta, and I'm joining these two ends. Assume that it is OPQ triangle. For our convenience purpose, I'm drawing a normal here. Now, so Qn value will be B sin theta. The reason is ONQ is like right angle triangle. So Qn value will be B sin theta. Now area of triangle POQ, I am taking it is A is equal to half into base into height. Here we'll take the magnitude alone. Half into base is nothing but acting as like A. Height is B sin theta. That is equal to half into AB sin theta. That is half A bar cross B bar under mod can be equal to AB sin theta. So this is nothing but the proof. Show that area of the triangle contained between the vectors A bar and B bar is 1/2 of the magnitude of A bar cross B bar. In the magnitude of A bar cross B bar into half is equal to area of the triangle. So this is the proof. Thank you. In the coming videos, we will discuss the rest of the problems. Please subscribe the channel.